Greetings and welcome to Lecture 6.8, Variation. So here's what variation means. If two variables are said to vary directly, if one is a constant multiple of the other. For example, let's say y varies directly as x. So if y equals k times x, where k is a constant, k is called the constant of variation. I know that was a lot of words there. K varies directly as x. So as y changes, x is going to change, but it's going to change by a constant amount. Okay? Or if x changes, y is going to change by a constant amount, which is k. K is the constant variation. We're talking about direct variation. Here's the type of statement. Y varies directly as x. So our equation is going to be y equals k times x, where k is the constant of variation. Y varies directly as the square of x. For an equation, that would be y equals k times x squared. S varies directly as the square root of t. In equation format, that is s equals k times the square root of t. R varies directly as the cube of s. So r would equal k times s cubed. Let's look at an example. Suppose y varies directly as x. When y is 15, x is 3. Find y when x equals 4. Well, here's the thing. This is a two-step problem. Number one, I don't know what k is. So I do need to first solve for k. Once I find k, then I can use k and my new x value to find out what y is. So I do know y varies directly as x, which means y times equals k times x. So when y is 15, x equals 3. So when y equals 15, x equals 3. So the only value I need to solve is for k. So 15 equals k times 3. Divide each side by 3. K equals 5. Now that I know what k is, I can solve when x equals 4, I can solve with what y is. So when x equals 4, y equals kx. K is 5, x is 4, so y equals 20. So it's going to be a two-step problem. Find k, the constant of variation, and then solve for your other variable. Suppose y varies directly as the square of x. When x is 4, y is 32. Find x when y is 50. Again, I need to solve for k first. Since y varies directly as the square of x, that's going to give me y equals k x squared. Now, using our first two values, x is 4, y is 32, I'm going to solve for k. So 32 equals k times 4 squared. 4 squared is 16. So 32 equals k times 16. Divide each side by 16, leaving me with k equals 2. Now that I know k equals 2, when y equals 50, 50 equals 2 times x squared. X is my unknown now. Divide by 2, divide by 2. X squared equals 25. I'm going to set this equal to 0, and I'm going to factor it and solve what x might be. So x squared equals 25 will become x squared minus 25 equals 0. I'm going to factor x squared minus 25 into x minus 5 and x plus 5, leaving me the possibilities of x to be 5 and negative 5. So I have two values that x can be to make this statement true. For the example, the cost of a certain kind of candy varies directly with 12 ounces of candy costs $1.68. How much will 16 ounces cost? So I know the cost equals K times the weight. So I'm just going to use C for the cost, and for weight I'll use W. So C equals K times W. When W is 12, C is 1.68. So 1.68 times K times 12. 1.68 equals K times 12. Let's divide by 12 for each side. So K is 0.14. That is my constant of variable, or variation. So when W, the weight, is now 12 ounces, that's wrong, that should be 16 ounces. When W equals 16, C will equal 0.14 times 16. So we should expect the cost to be $2.24. So that first part is direct variation. Now we're going to talk about the inverse variation. So the two variables are said to vary inversely if one is a constant multiple of the reciprocal of the other. For example, y varies inversely as x if y equals k over x, where k is a real number constant. So let's look at our statements here. Inverse variation statements would start off with y varies inversely as x. That's going to be y equals k over x. Y varies inversely as the square of x. Y equals k over x squared. F varies inversely as the square root of t. So f equals k over the square root of t. R varies inversely as the cube of s. So r equals k over s cubed. Now you may think, when will you ever use this? But you actually use this quite a bit in science. So when you get into physics and biology and engineering and all that good stuff, if you choose to go on to there, you will see these inverse relationships. Here's an example. Suppose y varies inversely as x. When y is 4, x is 5. Find y when x is 10. This is another problem where it's a two-step problem. One, we're going to find what our k value is. When we find our k value, we can plug it into the equation and solve when x is 10. So let's first find what k is. So y varies inversely as x. So y equals k over x. When y is 4, x is 5. So I'm going to solve for k. 4 equals k over 5. Multiply each side by 5. That gives us k equals 20. Now that we know what k is, let's solve for y when x is 10. So when x is 10, y equals 20 over 10, so y is going to equal 2. It's very important that you read through the problems very closely, because missing one word as direct, inversely varies, or directly varies is going to determine how to set up your equation. And you can see it means a whole different thing when you have x in the denominator versus x in the numerator. Here's a perfect example of how we can apply this mathematics, right? So the intensity I of light from a source varies inversely as the square of the distance from the source. So if you can imagine, you're walking away from a light source, it gets dimmer. So if you're really close, the light is intense, but if you walk away from it, the light is going to decrease in intensity. That's at least what we're going to expect. So 10 feet away from the source, the intensity is 200 candle power. What is the intensity 5 feet away from the source? So I need to first figure out the light source I varies inversely as the square of the distance. That's going to be I equals k over d squared. So now I'm going to plug in when D is 10 feet and I is 200 candle power. K, let's solve for K. 200 equals K over 100 squared. 100 squared is, 10 squared is 100. So now I'm going to multiply each side by 100 to give me 20,000. K is 20,000. Now, when the distance is 5 feet, and say I equals 20,000 all over 5 squared. That gives me I equals 20,000 over 25, giving me I equals 800 candle power. Okay. So let me just go back to the original and think about this. 10 feet away, the candle power is 200, whereas if we just walk 5 more feet, the candle power is 800. You see the difference. It's not just a one-to-one relationship. It does get brighter the closer I get to the source of the light, but it increases faster because when my distance is squared, it's increasing faster, or decreasing faster, however you want to look at it. Here's the problem I want you to work out and have prepared for the next class session. So the weight F of a body varies inversely as the square of the distance, D, between the body and the center of the Earth. If a man weighs 250 pounds 4,000 miles away from the center of the Earth, how much will he weigh at the distance of 5,000 miles from the center of the Earth? So try your best to work that out. Revisit the video if need be. So until next time, that's it for this lecture. Be seeing you.